Hello, everyone. My name is Chris Bergh. I'm CEO of DataKitchen, a Boston, Massachusetts, United States company that focuses on something called DataOps. And so we have a software product, but my talk today is not really about software. It's about this idea of something called DataOps and how it can supercharge your analytics agility. And so to do that, I'm actually going to go back in my background and talk about a period of my life from 2005 to 2008 as a way to set the stage for what DataOps is. And then I'm going to go into a little more detail, kind of technically what DataOps is and some examples. And at the end, sort of talk about the role of a DataOps engineer and what the benefits are for you. So I guess the first thing about my background, I spent 15 years as a software engineer working at companies like NASA and MIT and internet startups and enterprise startups and Microsoft. And then I got the bright idea in 2005 that I'd do this data and analytics things and this data and analytic thing. So I joined a company, had a team who worked for me who did what we call data science and data visualization and data engineering, although it had different terms back then. And honestly, I thought my life would be easy, but you know what? It was not easy. And so I had small kids at the time. I'd be at the soccer field, and then I had a BlackBerry, and I'd get an email on the BlackBerry or a text on the BlackBerry basically saying something broke, something's wrong, we're going to be late. And I'd have to slink off, and my wife would give me dirty looks. And my wife is great. I've been married to her now for almost 30 years. But, I know this is the second time or the third time, and I'm sorry, something broke. And then, I'd go and we did data and analytics, and we had a large number of users. We had sort of 5,000 or 6,000 users at one company. And the VP would call me up and say, Chris, you know what? The data's wrong. What's your problem? And I'd have to apologize to him and say, I'm sorry, it won't happen again. And then he'd say, look, Chris, if this happens again, you're out. And that was not very fun. And then I had, good intention data engineers and good intention people who did BI and analytics, and they'd make last minute changes in hopes to make their customer happy. And, they'd sit there and go, hey, it worked because no one's yelling at me. And you mean you made a change at the last minute? You didn't test it. You didn't know if it would work. You sort of hoped it would work. And it's been live for a week or two, and it's okay because you haven't gotten any calls. And then I just sort of got the Monday morning blahs. I sort of hate going into work every Monday because I invariably getting this nasty email. Hey, something's wrong. You suck. The data's wrong, or things are not right. The report looks funny. And then, of course, we had lots and lots of data providers. Sort of at the one point, we had almost 100 different data providers, and they forget that you exist, or they forget to send you data, or they suddenly change the meaning of the data. And, things we wouldn't notice it for a while. We'd get bad data and dashboards would go out, reports would go out, and whoops, what a surprise. They've been wrong. They've been wrong for the last month. And then, I worked for a company. We did healthcare analytics, and I worked for the CEO as the COO, kind of the guy who had to make the trains run on time. And my boss was a doctor, and he sort of looked at me like I killed a patient on the table. If I said to him, hey, we've got this new work to do in analytics. We've been thinking about it. It's going to take 2 weeks. And he'd grab his glasses and look down at me and say, Chris, I thought that should take 2 hours and not 2 weeks. And so we never really could go fast enough. And it actually made our lives miserable. And so I had one member of my team, a 24-year-old, he was what we called an ETL engineer at the time. And it was interesting because it was my 42nd birthday. And he came into my office and just was so upset. He couldn't make his customers happy because he wasn't working fast enough. He couldn't run things without it breaking. And it was just messing him up. He was sad and he cried. And he was a great guy. And, as a leader who's running a sort of dysfunctional team, my choice was to blame him or to fix it. And so, the further thing is that I hired smart people, and they had lots of favorite tools. Some liked R, some like Python, some like Tableau, not Click, some like using SQL and not Informatica. Everyone had their tool choice. And so after sort of working in this job, kind of complaining to my wife every night for years, she finally said, look, you're supposed to be a big, great tech guy. Why don't you fix the problem? And so I've been kind of on this journey of how to run data and analytic teams with all their different roles in a way that is fast, where you can deliver new insight quickly, where you can run that whole system with very, very low errors, and you can allow people freedom to innovate. And so I've kind of spent the last 15, maybe now 17 years of my life on this very problem. And my co-founders and I 8 years ago started a company focused on building a software product to solve it. And so it's not just us that have had this problem. So we did a survey last year of 600 data engineers. And I think that actually extends to other engineering roles in companies and data scientists and people doing data visualization, is that sort of half of them hope and pray things don't break. And 78% of data engineers are so stressed with their job, so caught between a rock and a hard place, that they need a therapist. And as a result, they were bolting. They're saying, they've built some stuff, it's problematic, I'm leaving. And so this is just a problem. And I think it's a problem from the psychology of teams. It's a problem because most of our data and analytic projects, and that could consist of some database, some report, some governance, some model, are failing in our customers' eyes. And it's not just me saying that, it's sort of lots of reports in lots of different ways from experts like Gartner and Eckerson and others. So let me talk a little bit about this. So what is the problem? So we're stressed out, things are unhappy. I've had that experience, projects are failing. Why is that? And so I think it has to do with this, is that all of us are really trying to do our next data task. And that could mean I've got a predictive model to do. I've got an algorithm to integrate. I've got a data pipeline to do. I've got to actually update my dashboard. I've got to update my governance. I've got to get new data itself into production. And we're always kind of focused on this backpack full of tasks. And really the challenge is that what's behind it, this data task focus, this sort of short-termism, we're missing, and we're causing these sort of great rates of team unhappiness and project failure. And so what I'm going to suggest in this is it's not about the data tasks, not that they're not great and not that they're not important, but how you do it, how you develop, how you iterate, how you deploy, how you monitor, how you test, how you automate. This upstream set of problems is actually just as important and in fact, some ways more important than the work itself. And what that means in some way is how you do things is important as what. And so what I've called this, and I think what the industry has taken hold, is this idea of data ops. And think of it as a set of technical practices and cultural norms and architecture patterns that really focus on four things. And that's what my talk is going to come out about today. And one is, how fast can you get something from your brain as a data scientist or a data engineer or an analyst into the hands of your customer? And how can you do that where they trust it and they trust the data and they trust everything that's happening to it, and by proxy you? And what I think of that as low errors, the inverse of trust is when they don't believe it. So having low errors and getting things fast into production or rapid cycles is really important. And then being able to collaborate, i.e. Work with high productivity, and then take these things like how productive your team is, how fast they can deploy, how well they can run their production systems with low errors, measure those things. So cycle times, error rates, collaboration, and measurement. That's what data ops is about. And it really comes from the same principles that people use to make factories better, lean ideas, the same principles that people use to make software better, and the same general agility principles. And so let's just talk about this in a very concrete way and give some examples of your typical data and analytic teams. And they may be arranged in different ways, but imagine you've got a data engineering team and a data science team and sort of a self-service BI team and a governance team. And, there's a lot of tools. And so just an amazing explosion of tools in the last 10 years to do things like data visualization, from from Cognos now to Power BI to Tableau to Looker to a myriad of new tools out there. And then likewise, in the last 5 or 10 years, there's been a bunch of data science platforms that are in the cloud or do auto ML. In addition, it used to just be SAS and SPSS. Now there's dozens and dozens, as well as there's a bunch of tools to put data in: Redshift, SQL Server, Synapse, Snowflake, tools to actually transform data, ETL and ETL catalog tools. And so there's just this massive fragmented tool chain. And so from our perspective, let's just talk less about the tools and what the people do. And so imagine there's the data engineers and they get a table of data and, it's got some names in them, some sales amounts. And then the data science team in all their wisdom segments the data and, creates high value and low value customers. And maybe they cluster it, maybe they use a rules-based approach, whatever, but they end up saying these are ways to segment my customers. And then there's a self-service team who actually could take that data and visualize it. And they make a nice chart that goes out to the VP of marketing, but maybe they mix in some of their own data, like who's the West team and who's the East team. And they might use a data prep tool that's embedded in their tool. They may use a calculated field, but they're adding some things in. And then finally, the poor data governance person has got to go back and say, well, where did this data come from? Who's the owner of the change? How do we help people understand this data? And so all these teams almost work separately from each other. The data engineering team, the data science team, the self-service team. Sometimes they're all under a chief data officer and he or she has the remit to make this whole system work. But a lot of times they're in different parts of the organization, sometimes working for IT, sometimes not, sometimes working for a line of business. And as you know, all of us get data from a lot of different systems. And DataOps really talks about building not transactional systems, but getting data from transactional systems and ingesting it into an analytic system that produces insight. And that analytic system that produces insight, I think, is best understood as a factory where data comes in as left and data is the raw materials. It goes through a series of tools, and imagine those tools are the workstations on a factory, the databases and blob stores and data tools and visualization tools and models and governance. They're all sort of things that are happening to the data. It's being assembled, things are being put onto the data, segments, visualizations, and it all happens kind of sequentially. Maybe it's a graph, but each one of those workstations is doing a specific part of the factory. And so like a factory, you want to make sure that the results, the data, and the things that are being added to data at the end, the thing that your customer sees, the business person, the end consumer sees, is something that they trust and something that they believe in. And so the problem is that most of these data and analytic teams, again, don't work for one person. And they are grouped into IT teams or data science teams or line of business teams. And so there's this rule that comes from, I think, from manufacturing. It came by a software called Conway's Law. And it's not a praise that says, the structure of technical systems often reflects the way teams organize rather than the ideal structure of that technical system. And so Conway's Law applies here a lot because, that journey, that factory is sort of distributed and companies have lots of factories. Sometimes they're called pipelines, sometimes they're called jobs, but lots of these factory assembly lines of data going on all at the same time. Some of them have lots of data, some of them have small data, some of them operate in batch, some of them operate in stream. It's really not about the data or the type of data. Think of it as the assembly process and how do you make a good assembly. And so you've got this sort of hard hat factory going on, but also you're actually trying to get things into production. And the thing that you're trying to get into production is code or configuration. And so you've got this idea of an innovation pipeline or a deployment pipeline, and that comes from software really. And so the challenge is you've got to do a lot of these things at the same time. You got to put your hard hat on and run a factory, but you've got to manage a software team and handle those hipsters. So how do you handle hard hats and hipsters at the same time when people are working all over the company? And so focusing, I think, on these ideas of lowering errors in production, decreasing the cycle time at which you can get things into production, and by that also the speed as well as the lowering the risk. And getting some measurement, you can drive fantastic productivity increases in your team on the order of 10 times. And I'm going to talk in price from the data on that. So let's go through some examples. So as a background, maybe you've heard these things, and these are typical complaints from people we found who come into the idea of data ops. One is that their customers are saying the data's wrong, the report's wrong, things look funny, and they're scared. Or the customers are saying your team's too slow, you got a backlog of stuff, and why is this all taking you so long? Or managers come in and say, like, I really don't know what's going on with my team. And I'm going to talk about this kind of as an example from three people. Let's talk about Eric, who's a production engineer, and Ahmed, who's a deployment director, and Stephanie, who actually runs a data and analytic team. You can imagine our data and analytic teams are kind of broken into a couple types. There's sort of a type of team who uses tools like Informatica and Cognos and Databricks, and maybe they're a more technical team. So maybe they've got a bunch of automation tools on top. Maybe they like Airflow and Jenkins. Maybe they are a big fan of AWS or Azure tools, but generally they're a more technical team. But there's also sort of less technical teams, and not to say that they're not bad, like they use tools like Alteryx and Tableau, more self-service tools. And sometimes these teams are completely separate. Sometimes, the technical teams also have self-service teams relating with them, but they all sort of have these needs of, I got to do the work, I've got to automate around my work, and then I've got to be able to test and observe what's happening in production for low errors in deployment. And so if you imagine a person like Eric, he wants to protect production. I've got all these pipelines running. I don't want to get yelled at. I want to protect and perfect the daily grind of delivering data. I want to minimize errors and chaos. And, I want a single pane of glass. I sort of want to understand what's going on and find if there are problems before my customer sees it. Prove that the raw data is right, the integrated data right, the model's right, the visualization is right, and nothing is going to go wrong, and know that before my customer sees it. And here's an example. So let's say you've got an Airflow job that runs on a 1 a.m. schedule. Let's say you got a Jupyter Notebook that also runs off a cron job at 4 a.m. And then maybe you got a daily Tableau extract. And so Eric's got somebody on his team. They got a checklist. Maybe they don't. But he wants to know, did it run? Is it late? Is something happened in the data? Did it all load? Did it all right? Are the reports still there? Are they making sense? Is the model still predicting? And, basically, am I going to get yelled at? Now, are my customers going to find problems? So here's another example. So imagine this is a customer that we've worked with. They've built a beautiful, what's called a telematic system. And that takes data from your auto, goes through a bunch of providers, and then it goes into a system that streams the data through this very cool architecture just done in the last 2 years that puts it in S3, uses Databricks to do ETL and some scoring models, uses Snowflake and HBase as a database, interacts with their policy system, and then goes into the Rides app. And basically it says, hey, put this little box in your car. It'll send information about your driving habits to the insurance company, and then you'll be able to get things done. So this complicated infrastructure that they built that's really cool is actually doesn't have a real owner. It's owned by some parts in IT, a Kafka event team, a data warehouse team, the policy app team, the front end team. And what they found is data was flowing through, it all looked good, but then when something happened, their customers would say, wait, I can't drive 1,000 miles in 1 second, or this ride didn't get all the way through, or where is my ride data? And so they had to respond to this, and then sort of finger pointing and pain would ensue. So I think one of the things is just sort of take your factory and make a factory, sort of observe and check what's happening in these data systems during production. So grab bits of data, grab the ride, see if it makes sense, see if you can actually, you can't drive 1,000 miles in 1 second. And what they wanted to do is take that data kind of sitting off the Kafka event queue and quarantine it. and alert to see if something's wrong. So actually monitor your production system, and don't monitor that it's running, monitor what's in the production system to see if it makes sense. Dig into the data, dig into the artifacts that are created from the data, and look at it through your customer's eyes. So it's not just about checking the raw data, it's about checking the integrated data, checking the data's interaction with other systems, checking to see that the model is still predicting in line, even checking the visualization to see if it makes sense. So this idea of production data ops, or sort of data value stream observability is I think a key point. And from a principal standpoint, is really observe automatically the data and the things that are created from data in production across every tool, across the entire value chain. And when you find a problem, send alerts and notifications, and keep track of the history that you've done it, because looking at the history is actually really important, and make it easy for people to create tasks. Because if you're going to check your report or check the data or check the model, these people have different tools and they like to use their favorite tools. And there's a whole bunch of ways to think about testing. One is sort of based on the data itself, profile the data and look for variations from the profile. One is taken right out of manufacturing. Look at variance over time, called statistical process control. You got 1 million rows and 1 million rows, and suddenly you get 100,000 rows. Well, that's interesting. Try to look at it from a system standpoint, follow the data as it bounces across your databases and load times and reports to see if it makes sense. And then finally, look at it through the eyes of your customer. Get at the end report, get at the end data set, and make checks against it. And sort of why do this work? Why sort of build a lattice of production value chain data tests across your system? Well, by driving low errors, it actually means you get more time for innovation and you get more customer data trust. And so I was talking with a head of a data team in the last month, very large company, one of the top 20 in the United States. He had a blank report. And that report, he found out it was blank, and it had been blank for several weeks because the CEO of the entire company called him up. So imagine you've got a data team, you have lots of people work for you. The CEO of the company says something's wrong. You get people together. In this case, you got 26 people, and it took them 6 hours to find the source of the blankness on the report. And of course, it wasn't anything interesting, but it took him, in his average time to change something was 6 weeks. And so that fact that report was blank decreases customer data trust, decreases customers of the routine. And you know what? Maybe it wasn't the report that was blank. Maybe it was something deeper in the value stream that ended up being blank. And so just focus on this and reduce the stress and embarrassment, and do that by building automation and automated testing and monitoring around your and observations. And so let's talk about the second part. And so let's imagine you've got something in production, your factory's growing great, but you've got to get new things, because of course your customers always keep asking questions. And so the person that you would think about is Ahmed, who's the person who's trying to get it into production. And their goal is to move things from a development environment into production, deploy them, but also do that in a way that has less risk. And really how to not make Eric angry, how to not break production through deployment. And so a lot of teams will actually deploy using tools called CI and CD. Sometimes it's manually, they'll manually use it. Sometimes they'll use CI and CD as kind of the railroad tracks to bring things from a dev environment to the other. But those railroad tracks also need signals. You need to be able to see, you need to test whether things work in development. And the best way to test in development is to take realistic data from your production environment, test data. Maybe it's all of the test data, maybe it's a smaller set of the test data, and pour it into your development system and run it and see if all those checks that you use in production are still there. And maybe you use all of them or some of them, but that way you can actually regression test or impact test the entire system. And that's really an important part, because you want to make sure if I make a small change or add a new features, I can judge. So don't have user acceptance testing. Don't manual test. Try to automate that and make sure that in your environments, you're not only not manually walking things from development to production, not also using a railroad, but you've also got the proper signals on that railroad that run automatically to tell you that things are going to work when you get it from development into production. And so, from that speed actually comes from testing, and that's sort of, you can use the same tests that you use in production, almost all of them, to run against the test data. And so it actually decreases the risk, decreases the time, because if you let a problem in development slip into production, the costs of fixing it are just 10 to 100 times higher. And so what is the principles that we want to talk about here? Well, first, automatically check in production. Make it easy to create tests, and don't just unit test, don't just check your piece. Pour realistic data into it and run that data against production. Maybe it's all data, maybe it's a subset of data, and find those regressions, judge the impact. And that'll really help you remove individual blinders to help. And why do this? Well, because you want to be able to hire new people. And you want to be able to take that 22-year-old just out of college and have them make a change somewhere. The database, the schema, the data set, the model, the visualizations, and know that when they make a change that it's going to work. Why? Because you've built this entire automated testing, automated regression structure around it. And once you do that, then lo and behold, the thing that you built, you no longer own. The thing that you built, you can handle off requests to more than one person. And then you start, the queue of customer requests goes down and down and down. You can more rapidly respond to what customers want. And when you can more rapidly respond, you can learn more closely what your customers want, and therefore avoid doing things that they don't want. And that's really one of the major points of agility, is that if you can maximize the amount of work that you don't have to do. Because if you spend, a customer tells you to do something, you spend 2 months doing it, you give it to them and they go, that's not quite right. I wanted 4 of those things, but you know what? 6 of those things I don't want. And you know what? I wanted these other 3 things. So you just wasted 60% of your time on building 6 things that they didn't want, and you didn't capture what they really did want. And so cycle time creates happy customers. Cycle time increases your learning rate. Cycle time decreases the amount of waste that you actually get in terms of your work. So by automating deployment, automating regression testing, you can get it there. And then the third part is, and I've been a manager, if you're a team leader, you're an analytic person, measure your team, be able to measure the impact of this. And here's a chart that comes out of our software. And let's look at the middle part. There's this time axis that goes across, and it actually shows in red the number of serious errors in production, the number of time it broke. But it also shows the number of automated tests that happen. And you can notice that the number of automated tests are going up. And look at the relationship. In the lower right-hand chart, there's something called the SLA. You're suddenly being on time. And you know what? With more automated tests, you're not having any serious errors. And therefore, in the upper right-hand corner, there's something called merges. You can actually deploy faster. And so this relationship between the amount of automation and automated tests, being on time, having less errors, being able to iterate faster, it shows up in this chart. And I think that's a really good thing to think about. And so I'm going to skip this. And what we've seen with our customers is that by building thousands of these automated tests, running them in development, running them into production, you can achieve incredible rates of change. You can have 100 changes, new data sets, new schema changes, new changes to a report with very, very little teams. And so we had a launch with a company called Celgene. It was a Tesla. It ended up becoming $1 billion brand, which is actually very rare. Most organizations who want to have $1 billion brand have a staff of over 100 people doing this work. And that work is error prone and problematic, and people are pulling their hair out. Well, this was done with a staff of 7. And there were very, very few errors, and actually a lot more got done. And so this idea of a 10x productivity improvement, 10x decline in errors shows up in our customers. And so, what's the best practice here? Well, first of all, I think if you're a bigger IT team, don't rip out what you currently have. Sort of sprinkle this data ops automation and testing kind of on top of what you currently do. And what that'll do is be able to help you increase the velocity of deployment, lower errors in production, and really measure what's going on with your team. And so now if you're a smaller team, let's say you're a team that sometimes there's these hub and spoke where there's a big central team and then there's self-service teams, and or you're just a small team that uses tools like Alteryx and Tableau and Power BI. Well, you've got to be able to automate, right? And there's a and let's look at this example of challenges of hub and spoke teams. And so let's say you've got a home office team and they have a data engineer and a data scientist, and they build a database in SQL Server, right? And that database has got some segmentation in it. They're in Boston. And let's say they're a good data ops team. They make, they have lots of automated tasks. They make changes every week. Well, there could be lots of self-service teams that utilize that data, and they could be in New Jersey or California or Mexico or somewhere else. And those analysts use some tools like Alteryx and Tableau. But the sum of their work, the sum of the home office team plus the specific self-service team goes off to a business customer. Now, if there's problems with that, right? What happens when you want to make a change? Who does the change? Let's say the change happens in the home office, they change the schema. Did that break every report on every local office team? Did the self-service team add a new small data set? Well, where does that live? Shouldn't that live in the centralized data warehouse? Sometimes these self-service teams in different teams, different locations have different report calculations. The different definition of market basket. It's calculated one way and calculated another. Well, they should be inconsistencies. And then just how do you coordinate when a central team makes a big change? Do you have to have lots of meetings? Do you have to call people? Do you have to nag people? And so our view is that all these things should be automated. You should be able to make changes quickly in this hub and spoke environment and deploy quickly. And the key here is actually to think of it as a system. Be able to say, okay, I've got my self-service team. I've got my automation that's doing this checking, but I've also got my self-service team. And both teams are plugging in their favorite tools. Both teams are working independently, but there's a system on top of it that's saying, I changed something in the back, let me run the front to see if it works. Or I've changed something in the front, let me see how that compares to what other teams in the front are doing. And this sort of shared responsibility, separate results, but coordination across, I think, of the process in a hub and spoke manner is a very important technique that can solve one of the long-standing Hatfield to McCoys or self-service teams think the central IT team's morons, the central IT teams thinks the self-service team's a bunch of cowboys, and the customers just sit there pulling their hair out why they're not getting good insight. And so let's talk about this role of data ops, but let's talk about the person and the responsibility for it and then we'll finish up. So what is a data ops engineer? Well, the data ops engineer, think of them as owning the assembly line. And that assembly line is really to enable data engineers and scientists and analysts and governance to deliver insight rapidly with low errors. They own the pipelines that run the process, the innovation and value pipelines. And they work on those factories, those pipelines, but not in them. So they don't do data engineering. They don't do data science. They don't do data visualization. They develop automation and testing around it. And, they're kind of the hub, between data scientists and data engineers and self-service analysts and BI analysts and doing data governance. And it's really about collaboration and enabling those teams. How does and what the challenges that a lot of data ops engineers run into is like, well, I've done something, can I throw it over in a prod? Well, what does really done mean? And so in a lot of ways, the challenge of data ops engineering is definitional. What is done and what is good? And so what is done doesn't mean that your model works on your machine or that your SQL code works with a unit test or that I've got a new report. It means done means in production. Done means in production with automation and testing around it. And good means someone's used it and I can run it with no work. And there's sort of a set of focusing on tasks, sort of a willful blindness to the production, kind of a lot of hope. I hope something works. A lot of reliance on manual as opposed to automation, and kind of a general lack of willingness to sort of pull the pain forward. And so these are the problems that data ops engineers run into. But I think one of the ways is about collaboration through shared abstraction. And if you could see the work from a data ops engineer, the nuggets that people create. I'm a data engineer, I create some SQL, some ETL code. I'm an analyst, I create some XML, some JSON, my report. I'm a data scientist, I have a model, which is some data and some Python code. I have data governance, which is, again, could be expressed as configuration code. And that's sort of put into pipelines, automated with tasks, run in a factory, automating deployment, works across people, and enables success. And also that shared abstraction enables people to see their local versus whole interaction. And in some ways, data ops engineers are making what's invisible visible. And so, I think these tasks, production orchestration, data monitoring, testing, environment management, regression and functional tasks, developing shared components, developing measurements are really some of the challenges that people have. And I think a lot of times doing this work is that it's not owned by anyone. And the perception is that it's not worth doing, or I do it on nights and weekends. And it's kind of, we've always done this. And I think manufacturing's seen this, the software industry's seen this, and really it comes down to automation. And really, if you can develop automation and automated testing and focus on those tasks, you can be successful. It's about automation, and it's about the time that you spent. And I'm going to call your attention to this one on right here on the rightmost bar chart. When I took software teams, your average software team today spends 23% of their time on this automation and testing and quote DevOps tasks. And 20 years ago, when I ran software teams, it was sort of 1%, right? 2%. And so why are software teams spending upwards of a quarter of their team effort on automation, testing, on not doing the work, not creating the nugget, but the system, the tool, the how around it? Well, because they've learned that building that actually enables the other 3/4 of the team to be much more productive, to work much quicker, to deliver with higher quality. And so that's kind of the big argument here, is that how about we just start with 15%? 15% of our time is spent on automation and testing and improving the process, improving the how that we work. And if we do that, we're going to have excellent results. Our customers are going to be happier. We're going to get more done. We're going to do it with higher quality and less errors. And so how to think about this? Well, let's just think about it a very big picture. And so what we've done in surveys we've done show that a lot of data and analytic teams, their cycle time to deployment with low risk is weeks or months. It's very rare that they go without errors, or maybe they don't even know if they're having errors or things that are wrong. They have a lot of meetings and they have no idea what's happening with these major process metrics. And so the idea of that is that this actually ends up being very costly. Teams are productive, projects are failing, and your customers are unhappy. And so the idea of data ops is you can take this graphic equalizer and you can improve your cycle time, and you can increase the number of days with no errors. And your collaboration can get easier. You can have less boring meetings. You can push up all these things. And it's not a trade-off. It's not like, oh, I can go faster, but we're going to have more things break. Or I can have less things break, but we're going to go slower. And so that's the trick here. And if you do all that, you actually drive productivity down. And so best-in-class companies are actually achieving all this. And that's the challenge, because a lot of people who have been in the data and analytics field don't believe that you can do this all at once. They always believe it's a trade-off. I go faster or things break. And so in some ways, it's about heroism and fear. And so a lot of teams will lock in on fear. I'm going to go slow so I don't get yelled at. Or they're going to lock in on heroism. I'm working nights and weekends. They get burnt out. And so the DataOps idea, in fact, all of Agile principles are about that balance between heroism and fear. And the DataOps, as well as the DevOps idea, is that by automating, by spending that 20% of your time on automation, 15% of your time, you can achieve these results. And so our customers have seen it using our software. And so I'm not going to go into that. But also, we've spent a lot of time trying to educate people on this, on these principles. And so if you're interested and have just time for one page, go to the DataOps Manifesto. It has these ideas in 18 points. We have a cookbook that's a little longer, 165 pages with lots of pictures. We have a second book that talks about how to change your team. And we even have a certification program, 3 hours, and you get a certificate. So thank you for your time. If you want to learn more about DataOps and DataKitchen, go to datakitchen.io or look at these links on the slide. I appreciate taking the time. And again, I'm Chris Bergh from DataKitchen.